Hello, and today's learning target is I can find the x and y intercepts from a graph or table of values. I can interpret the x and y intercepts from a word problem. So let's talk about what x and y intercepts are. And we already have spoken a little bit about what they are, specifically the y-intercept, but now we'll introduce the concept of x and y intercepts and how to find them. So the x-intercept is where the line passes through the x-axis, or when y is 0, what's x? Similarly, the y-intercept is where the line passes through the y-axis, or when x equals 0. So again, it's with your intercepts, it's when the opposite variable equals 0. So let's take a look at these graphs. Okay, so let's look at this first graph. So let's find the x-intercept. This is where your line crosses the x-axis. So this is the x-axis here. So where does that line cross? Well, that would be right here at 2. So the x-intercept is 2, and we'll always write that as an ordered pair because it is a point on the line. So we want to reference that by saying, yep, it's an ordered pair. The y-intercept, here's the y-axis. And where does that line cross the y-axis? Well, it's right there at -2. So that will be 0, -2. And again, with ordered pair form, 0 goes in the place where, or 0 goes in the place of the opposite variable. So remember, x-intercept, if it's at 2, 2, 0. Y-intercept, that's always the second number listed in ordered pairs, so it would be 0, -2 for this example. Let's look at the next example. Okay, so let's look here. Where does the line cross the x-axis, and where does it cross the y-axis? All right, so where this crosses the x-axis would be at -3. So I'll write -3, 0. And then where does this line cross the y-axis? At 2. So I'll write 0, 2. So again, when we're looking at a graph, we want to look at where does that line cross the two different axes, and then again write those intercepts as ordered pairs. All right, now let's look at an example with a table. So again, keep in mind the big idea is when is the opposite variable equal to 0? Then that's the intercept for the specific variable we're looking at. So if I were to look here at my table, I see the first 0 I see is, is right here. So when x is 0, y is 8. That's the y-intercept because, again, the opposite variable has to be 0. So y-intercept is 0, 8. Now the x-intercept is when y is 0. So here the x-intercept is 6. And again, I'll write that as an ordered pair. So 6, 0. Oftentimes it can get mixed up that you think, well, when that variable is 0, what is the solution? Like for x, when x is 0, what's y? So sometimes students think, oh, the x-intercept is 8. Nope, again, you got to remember, it's the opposite variable is 0. Right? And so sometimes that can be easily mistaken. Don't get those two mixed up. And again, don't forget ordered pair form. Now we are going to look at x and y intercepts from word problems, and we're going to connect what these intercepts mean within a real life situation. So let's take a look here at the first example. A swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time in hours that the pool has been draining. Find the x and y intercepts of the graph of the function. Describe what is happening at these points. So as we look on our axes, right, and I can highlight them again, right, my x-axis and the y-axis, and I want to find those intercepts. So the intercepts would be right here and right here. So what that means here for the y-intercept, well, or what is the value of that? That is 0, and then the volume it looks like is 10,000. So 0, 10,000. So what that means is there are 10,000 gallons, right, volume in gallons, of water in the pool to start with. So we'll write that down. there are 10,000 gallons of water in the pool to start with, or to begin with. So to start. Now the x-intercept, where does that line cross the x-axis? At 14. So we will say here 14 comma 0. And so what this means is, if you can, reading the labels and reading the description that we had just read right above, this visual is that we're draining a pool. And so it starts with 10,000 gallons of water, and eventually we want to get that down to no gallons of water, right? We're draining it. So the time is on the x-axis, and that time is at 14, right? So it took 14 hours to actually drain the pool. So that's what the x-intercept means. It took 14 hours to drain the pool. Okay, let's move on to the next example. The table shows the function relating the distance to an amusement park in miles that the time in hours the Taurus family has driven. Find the x and y intercepts. Describe what they mean in context. So looking at the table, as you recall from the last slide, we wanted to figure out when the opposite variable was 0. So if I highlight a couple important pieces of information in the table, this one's important and this one's important, right? Because I see somewhere there's a 0. So let's start with the y-intercept. And y-intercept usually means, at the beginning, or when things begin, what was there to start with, or what needed to be accomplished. So here at time 0, right, the hours is 0, distance in miles that the family has to drive is 248. So the y-intercept is 0 to 48. So if we write this out as, a sentence, this means they, or the Taurus family, needs to drive 248 miles to get to the destination, which would be the amusement park here. Then the x-intercept, right, is where y is 0, and that'd be the red highlighted numbers, which would be 4, 0. And what this means is that at 4 hours, the distance that they still have to travel is 0, which means they're there. So it took the Torres family 4 hours to get to the amusement park. Must be a pretty good amusement park to drive 4 hours there, right? So we just looked at word problems that we had to figure out what are the x and y intercepts, and then what they mean in context. So that means writing a full complete sentence to describe what those intercepts mean. Thanks for listening. Have a great day. Bye-bye.